definitions to determine if something is a logical proof or not. Okay? So, what we're going to be talking about today is basically proofs, and let's get some autofocus on that. Okay. And the question becomes, are they valid or invalid? Okay. So, we're discussing valid or invalid proofs. We have the valid proofs. And so the valid proofs the first one is going to be universal modus ponens. Okay, and on the homework assignment on the test, you're going to have to determine which type of proof we're actually dealing with. So the question will actually be, is this universal modus ponens, universal modus tollens, or inverse error, converse error? And so universal modus ponens says that for every x, if p of x, then q of x. Okay. Now, if you have for every if and then statement, okay, then you say, all right, well, let's say if P of A is true, for a particular A, actually you can drop that if statement. Therefore, you can say Q of A. So this one's kind of straightforward. This is just saying if you have a statement, and then you say, all right, the statement says that for every x, if P of x is true, then Q of x is true. And then it just says, well, we're going to pick a particular x, and we'll just call it A. And so if P of A is true, well, then therefore Q of A has to be true. Okay? So this is just a straightforward if and then statement. Okay? Another way this is referred to is universal instantiation. My pronunciation of that is terrible. But if an element is true for the entire set, then it is true for any particular part of the set. Okay? Okay, another valid argument sure everybody has that written down. So we have universal modus ponens, and then we have universal modus tollens. Okay. And this one says, well, for every x, if P of x, then Q of x. Okay. Well, and it says, no, we'll leave that if statement right there. Why not? If not Q of A, then we'll say, therefore, not P of A. Okay, so what is this statement saying? If you have some type of logical argument, you're saying if P of X is true, then Q of X has to be true. Okay? Well, what if Q of X is not true? Okay? Well, then that would imply that P of X is not true. Because Q of X is only true if P of X is true. Okay? Okay. So these are the two valid arguments that you can do. And if you want to think of this in a way that we were talking about in class last time, you can think of this as the statement and the contrapositive, if you want to think of it in that sense. Okay? But then we have invalid arguments. Okay? And then we'll do a whole bunch of examples about the difference between these. Okay, so we have our two valid arguments, which are the two universal arguments, which is basically the statement itself and the contrapositive, arriving at a conclusion of that. Okay? All right, so we have the statement, it's contrapositive, and then we have the converse and the inverse. And so those give rise to the errors. Okay? The converse error says that for every x, if P of x, then Q of x, so we have our normal statement, okay? And so then we could say if Q of A, let's say is true, a particular this is an invalid argument. Okay, and one of the classical examples that we've been talking about is the difference between continuity and differentiability. Oh, somebody is asking what A represents. A represents just a particular solution. So given a particular solution at a point, so let's phrase this in a way that we were talking about in class last time. So if a function is differentiable, then it is continuous. Okay? Now, if a function is continuous at a point on a graph, that does not mean that it is differentiable at that point. Okay? So that would be an example of converse error, although it can be expressed in multiple different ways. Okay? So that's an example of converse error, but we'll get into some actual examples as soon as I get done with the definitions. Okay, so that's a converse error. And then we have an inverse error. Right? And so this is going to say for every x, if P of x, then Q of x, that's our statement. Let's say if the negation of P of A, say therefore, the negation of Q of A. This is an invalid argument. Okay, so we have our two valid arguments and our two invalid arguments related to the statement itself, the contrapositive, the converse, and the inverse. Okay, so let's see how we would apply these to a situation. And sometimes the language of these problems can actually be pretty confusing. So, let's look at a set of statements, okay? And some of these will be a little bit goofy, but then I'll get into some real ones that I would incorporate in some of my more advanced classes. So, let's see. All healthy people eat an apple a day. And we can say, Keisha eats an apple a day. Okay. So we have our two statements. And so from these two statements, we can say, therefore, Keisha is a healthy person. Everybody, a second to write that down. And then we're going to examine the situation and see, is this actually a valid argument or not? I'll give everybody a second just to write that down. We check the chat box. Okay, and somebody did ask, what was A in this problem? A is Keisha. It's a particular person of the set of people. Okay? And now, reading this statement, a lot of people would just look at this and say, well, that makes sense. Keisha eats an apple a day. That means she must be a healthy person. Is there any type of flaw in this logic? I mean, the question could be phrased in this way. Could it be possible that Keisha eats an apple every day and she is still not a healthy person? Yeah, she eats an apple every single day, but every single other meal is followed by Whataburger or something like that. Okay? So, Keisha can eat an apple a day. That does not necessarily guarantee that she's a healthy person. But this statement says that all healthy people eat an apple a day, which is not necessarily true, but we're going to go along with that statement. So let's try to write this in terms of the variables and the statements that are going on inside of this problem so that it actually matches up with the formal logic that we are using to determine if this is a valid or invalid argument. Okay? Okay, so the beginning of this problem says all people, all healthy people, or all people who are healthy. Okay? So, if I was going to write this as a logical argument, for all people, okay? Now when I talk about all people, that's my X. Okay? Now, if healthy, okay, that would be my P of X, then eat an apple a day. Okay, so that right there is going to be my Q of X. Okay, So for all people who are healthy, they eat an apple a day. Okay. All right. Now we have the next statement. Okay, so let's put a period at the end of that one. Okay. Then the next statement says, Keisha, where is it? Oh, we started with an E. Okay, so now Keisha is my A. This is the particular. Okay? And then we can say Keisha eats an apple a day. Okay? So we have our individual person, and then we have the argument that, well, Q of A. So in this type of argument right here, we have for all people, for all x, if P of x, then Q of x, and then we say we're taking a particular person from the set and saying, well, Keisha, she eats an apple every day. And then, but the conclusion states, I'm gonna run out of room. Okay. Therefore, all right. And so what would this correspond to? Well, this is still A, but this is, all right, so Keisha is A, and healthy corresponds with P of A. All right. So if we look back at our previous arguments, okay, so we have for every x, leave that up for just a second. All right. Now for every x, if P of x, then Q of x, and then we said, all right, Keisha eats an apple a day. So we're taking a particular person and we're saying, yeah, that corresponds with the Q, eating of the apple. And then saying, therefore, Keisha is healthy. What does this correspond with? This corresponds with a converse error. So we're saying for every person, if that person is healthy, then they eat an apple every day. Okay? And then we said, well, if Keisha eats an apple every day, Keisha being our A, our particular person of this set, well, therefore, she must be healthy. Well, no, this is an invalid argument. This is a converse error. Okay? And if you want to think about this in terms of maybe a diagram, let me use a piece of paper so I'm not using up too much. Let's say if we were going to draw this as a Venn diagram, let's say this is the bigger set of people that eat apples. And a subset of that is the healthy people. Okay? So, we made the statement that Keisha eats an apple every day. All right? Well, she has to exist within this outer set. But That doesn't mean that she exists within the smaller set, so it doesn't necessarily mean that she's healthy. Okay, so that's an example of a converse error. Okay. Okay, so let's do one that involves, instead of kind of generic terms of eating apples and stuff like that, let's say, well actually, let me stop this video because that's already 20 minutes long.